How does negative feedback stabilize op-amp circuits? Imagine trying to keep a bicycle steady on a bumpy road. You constantly make tiny adjustments to stay balanced. That's similar to what negative feedback does in an operational amplifier circuit. It helps keep the output steady and predictable. Operational amplifiers are like supersensitive microphones. They can amplify tiny voltage differences between their to-input terminals. Their open-loop gain, which is how much they amplify without any feedback, can be around 100,000 or more. This means even a small difference at the input can cause the output to swing wildly. Without some control, the circuit can become unstable or produce distorted signals. Negative feedback comes into play by connecting a part of the output back to the inverting input terminal. This connection forces the operational amplifier to adjust its output so that the voltage difference between its two inputs is nearly zero. This condition is often called a virtual short because the two inputs are at almost the same voltage, even though they are not physically connected. When the output tries to go high, the feedback makes the amplifier reduce its output. When it tries to go low, the feedback makes it increase again. This balancing act keeps the output stable. Because of this, the overall gain of the circuit, called the closed-loop gain, depends on external resistors rather than the internal gain of the operational amplifier. For example, in an inverting amplifier, the gain is set by the ratio of two resistors. This makes the gain predictable and stable, even if the operational amplifier's internal characteristics change. Negative feedback also helps the circuit handle a wider range of frequencies. The open-loop gain of an operational amplifier drops as the frequency increases, but with negative feedback, the gain remains steady over a broader frequency range. This means the circuit can amplify signals more reliably across different frequencies. Another benefit is that negative feedback reduces distortion and makes the output more linear. It corrects any deviations from the desired output, ensuring the signal stays true to the input. However, if the feedback network or the operational amplifier itself introduces phase shifts, it can cause oscillations or ringing. Many operational amplifiers include internal compensation to prevent these issues. In real-world electronics and embedded systems, negative feedback is essential. It helps design amplifiers, filters, oscillators, and other analog circuits that perform consistently under different conditions. It makes sure the circuits meet their specifications for gain, bandwidth, and stability. To sum up, negative feedback stabilizes operational amplifier circuits by controlling the gain through external components, forcing the input voltages to stay nearly equal and improving bandwidth and linearity. It also reduces the circuit's sensitivity to internal variations and external influences. These are the core principles that make negative feedback a fundamental tool in analog electronics design.